So, have you ever wondered how modern software gets built so fast and, so reliably? It's not magic, that's for sure. It's actually an automated process, a finely tuned assembly line that takes your raw code and turns it into a finished product, humming along in the cloud. Today, we're going to walk that line, step by step. All right, here's our game plan. We're going to follow a piece of code on its entire journey. We'll start with the gatekeeper on your own machine. Then we'll move through building and testing, see how the CI/CD engine really powers the whole thing. And finally, we'll talk about why this process is, no joke, a modern developer's superpower. Let's kick things off with a problem that every single one of us has faced. I'm talking about those endless manual tasks that are not only a total drag, but are also super easy to mess up. This is where those dreaded "it works on my machine" bugs come from. There has to be a better way, right? And that really is the million-dollar question, isn't it? I mean, what if we could build a system that just automatically catches all the small mistakes? A system that enforces coding styles so you never have to argue about it again, and frees up our brainpower to focus on the actual hard problems. Well, that's exactly what automation brings to the table. The solution is to think like a factory. We're going to build a software assembly line. It's a workflow that takes your code from just an idea all the way to production, and it makes sure that every single step, from compiling to testing to deploying, is done the exact same way every single time. No more guesswork, just consistent, high-quality results. Every good assembly line has quality control right at the source. So our first stop is an automated gatekeeper that runs right on your own computer. This makes sure that nothing faulty even makes it onto the main conveyor belt to begin with. We're talking about something called pre-commit hooks. Now, you can just think of these as an instant quality check. They're just little scripts that run automatically every time you try to commit your code. They act like a personal bouncer, catching silly mistakes before they ever get pushed and waste your team's time in a code review. Think of it as your own automated checklist. These hooks handle all those small, tedious things that are easy to forget. They'll clean up white space, make sure your config files are valid, and automatically reformat your code to match the team's style. And maybe most importantly, they can be a total lifesaver, catching things like a forgotten debug statement or, even worse, secret keys you accidentally left in the code. And the best part is that getting all this set up is way easier than it sounds. It's all managed in one simple configuration file, .precommit-config.yaml, that just lives in your project. You just tell it which hooks you want to use, and the framework handles all the rest. It's pretty slick. Okay, so your code made it past the local gatekeeper. It's clean, it's formatted, and it's ready for the big time. Now we're entering the main assembly plant. This is where your source code gets transformed from a bunch of text files into an actual working piece of software. This is the job of a build tool. You can think of it as the heavy machinery of our factory. It takes your raw code and just automates that whole complex process. It compiles everything, it pulls in all the libraries and dependencies you need, and then it packages it all up into a single runnable file, like a jar file. And you'll see these kinds of tools in basically every ecosystem out there. The names might be different, whether it's Gradle for Java or NPM for JavaScript, but the core idea is always the same. Create a reliable, automated way to build your project. So our application is built. It's a real thing, but now it's time for probably the most critical step. Quality control. We can't ship a faulty product, but here's the thing. Not all tests are created equal. To be really efficient, you need a strategy, and the best one is called the testing pyramid. This whole idea, made famous by Mike Cohn, is really a cornerstone of modern development, and the key insight is actually pretty simple. Focus your effort where you get the most bang for your buck. A big, solid base of fast, cheap-to-write unit tests gives you the biggest return on your time by catching bugs super early, when they're easiest to fix. So what does that look like in practice? Well, it's a mix kind of like this. You want a really strong foundation, maybe 70% of unit tests. Then you layer on some integration tests to see how the pieces work together. And then you top it all off with just a few big end-to-end tests that check the whole system. So let's zoom in on that foundation. A unit test is all about verifying one tiny piece of code in complete isolation. You're testing a single function and nothing else. That way, if the test fails, you know exactly where the problem is. This makes debugging incredibly fast, and it's why they're the base of our whole pyramid. So we have our local gatekeeper, we've got our build plant, and our quality control station. But how do we connect it all? How do we make this a smooth, automated flow? Well, that's the job of the CI/CD engine. It's the central conveyor belt for our entire assembly line. CI/CD, you hear it all the time, stands for continuous integration and continuous delivery. And it's the automated pipeline that glues everything together. The second a developer pushes code, bam, a trigger fires off. A CI server grabs the new code, runs the build, and then executes our entire pyramid of tests. If every single check passes, it packages up the final product and gets it ready for deployment. This is the engine that never sleeps. And just like our pre-commit hooks, this isn't some super complex, abstract thing. It's usually defined in another simple text file right in your project. This here is a real-world example from a GitHub Actions workflow. You can see, on every push, it installs dependencies, runs the build, and then runs the unit tests. It's simple, it's clear, and it's incredibly powerful. And this isn't some niche idea. This is absolutely the industry standard now. It doesn't matter if you're using GitHub Actions, GitLab CI/CD, the old workhorse Jenkins, or a cloud tool like Circle CI. The core principles are the same everywhere you look. So we've done it. We've built our entire automated assembly line. We've gone from a single line of code on your machine to a fully tested application that's ready to ship. So what's the big payoff? Why should you, the developer, actually care about all this? The benefits are just massive. You save so much time and mental energy by not having to do boring, repetitive work. You find bugs way earlier when they're 1,000 times cheaper to fix. You get this amazing safety net of tests that gives you the confidence to refactor and improve your code without being scared of breaking something. All of this lets you ship better code faster. And your tests, they become living documentation for how your system actually works. Ultimately, this isn't really about the tools. It's about building a system that frees you up to focus on what actually matters, being creative, innovating, and solving interesting problems. So your automated assembly line is ready to go. The only real question left is, what are you going to build with all the time you just got back?